Hey, we're back. Sorry, I'm going to move myself down here. So this is video 19, and this is a kind of culmination of our video series on statistical significance and hypothesis testing. So we're going to do some two-sample t-tests, and in particular, or rather, we're going to do two-sample t-tests because that is kind of how we think about in political science whether a given difference is statistically significant. And in particular, so here's some examples. And again, you can see that my notes are up, and these notes are going to be on Blackboard very soon. So a common question is group X systematically different from group Y on some measure? So are Republicans wealthier on average than other people? And in the US context, yes, they are. Are women more likely than men to support abortion access? Yes, they are. Statistically speaking, it's both substantively and statistically different. Did the climate change condition in our class's survey experiment make people more likely to report that climate was a key issue? And we don't know, but I'm hoping to analyze that this week. So the way to look at these differences, that is to say differences between groups, is with a two-sample t-test. And you can see in the notes that I have marked out which things I think are independent variables and which things I think are dependent variables. And so with a two-sample t-test, we use the code t.test x tilde y. Tilde is shift, and a key in the upper right should be just to the left, or sorry, upper left of your keyboard, just to the left of the number 1. And the code goes t-test x tilde y. X is the dependent variable, that is the thing whose means, the measure on which we're comparing means. And y is and this is important, a binary independent variable. So Republican or not, binary independent variable. Woman or not, binary independent variable. Did they receive the climate change condition or not in our survey experiment? Binary independent variable. And so I made a little, again, this is sort of a toy example that I made up. I have 3 binary variables. Women, which means do they identify as a woman? Abortion, meaning do they support abortion access or legal abortion access? GOP, meaning are they members of the Republican Party? And yearly income. So it's not it's made up data, although it does hew somewhat to average values in an American sample. But mostly this is going to be for our purposes in testing. So let's start with the kind of first example. Are Republicans wealthier on average than other people? So to do that, I'm going to type t.test and see that this data set is called X $, income, that's the dependent variable that we're comparing, tilde, X $, GOP. And in the sample that I've created, kind of by design, we have a p-value of 0.006. So we think it is we think the likelihood of getting a difference this big, if the true difference in means was 0, the likelihood of getting a sample with a difference this big would be about 0.67%. And so, because that's definitely less than 0.05, I would go ahead and reject the null. And the null, remember, is that there's no difference in the average income of Republicans and other Americans, or Republicans and non-Republicans. Another way of checking that out is to look at the 95% confidence interval and ask yourself, does it cross 0? The confidence interval here does not cross 0, goes from about negative 6250 to about negative 1010 or 1011. And because the confidence interval of the difference between these two means does not include 0, we're going to reject the null hypothesis. So you can either look at the p-value or look at the confidence interval. And notice it says, oh, it's a Welch two-sample t-test. That is the right thing to do in this particular case. Yeah. Let's do one more example. So let's say we ask, are women more likely than men to support abortion access? You'll notice that these are both binary variables. Now, in a two-sample t-test, your independent variable must be binary. Your dependent variable may be binary. So let's see what happens when we go t.test x abortion tilde x women. All right, so in this sample, the mean in group 0, that is to say non-women, is 0.42. 42% of those people support abortion rights. In group 1, people who identify as women, it's more like 60%. And this is a very significant difference. So you can see that the p-value is expressed in, it's so big that it's expressed in scientific notation. So 7.375 times 10 to the negative fifth, or about 0.000007. Very low p-value. So in this case, again, we reject the null hypothesis that the true difference between women and non-women is 0. And that is good evidence for an alternative hypothesis that there is a difference between women and men, or, right? This is a little tricky. Women versus men is not quite the same as women versus not women, but I think it's a fair approximation for a couple of reasons. In any case, we do reject that null hypothesis. So I want to draw your attention to one last thing, which is that the output for a two-sample t-test is a little bit different than the output for a one-sample t-test. So let's just look at a one-sample t-test. The mean across all people in our sample is 51% of people support abortion access. That's quite different from 0. And consequently, the p-value is tiny, but we're not that interested in the p-value. We're interested in the 95% confidence interval, which is 46.4% to 55.2%. And so that's, right, you can use that to reason as you will about the sample, about the true state of the population in terms of opinions about abortion, etc. But notice that in a one-sample t-test, for one thing, it says one-sample t-test at the top. In a two-sample t-test like this one, it'll say two-sample t-test. It will show you, in a one sample, it just shows you the mean of that sample. In a two sample, it shows you the means of the two groups. And the other key difference is the null hypothesis. So with a one sample t-test, the null hypothesis is that the true mean is equal to 0. With a two sample t-test, the null hypothesis is that the difference in means is equal to 0. Kind of like we talked about in the last video. I know, it's amazing. So one way to check, just to recap, if a given difference between two populations is statistically significant, you run that t-test and you ask whether the confidence interval of the difference includes 0. And if it does, then the difference is not significant, right? If the confidence interval goes from -100 to +100, well then it seems unlikely that the true difference is necessarily more on one side than the other. So we don't reject the null in that case. Okay, we're going to talk about this more in class, but for now I will leave you and I will see you soon.